One more minute, and then we're off again. Just a quick feedback round. Can you give me any kind of non-verbal indication of what the day's doing for you so far? Like a little wave or a hand clap? Thumbs up. Oh, Ben, yeah, can you do that again, please, and stand up? That's so lovely. That's so VUX, right? Well, that's great to see and great to hear. Well, welcome again. Great to see that so many people have actually stayed in this room, because it's definitely worth it. Because our next speaker, well, we go back a little while, right? I've had you as a guest in Convo Club, Thomas Rinfus from Amazon Lex, and I'll probably just leave the topic up to you because it's so all-encompassing and it's about voice. So enjoy. Here's Thomas.
Hi, my name is Thomas Rinfus. I'm a senior solutions architect for Amazon Lex at Amazon Web Services. And today I'm going to talk a little bit about a solution that we've built called the Q&A bot on AWS. And it's really an easy way to increase call deflection or chats across multiple channels and multiple languages by answering customers' most frequently asked questions. And we see this as an accelerator. So we have Amazon Lex, which allows you to build conversational experiences, of course. It's our conversational AI platform. But a lot of customers, they just want to get started really quickly without needing to have their own team to build something. And this is something that you can deploy out essentially in 45 minutes. Well, that's what it takes to deploy it out. Then you have to put your questions in. That's going to take a little bit longer. And I'm going to focus specifically on our most recent release of Q&A bot, which gives you the option of using a large language model to improve the intent matching. And like some of the speakers today have indicated, it requires a lot less training data when you're using a large language model for that intent matching. I'm going to go pretty deep on the how over the next 20 minutes, so I hope your eyes won't glaze over. And I still want to point out that this is still, we still refer to this as an experimental release. We've played around with it. It seems to work really well. But make sure to test it out in your dev environments before you just throw this into production. So Amazon Lex is our conversational, give me a second here. It's our service for building conversational interfaces for voice and text. So it lets you build sophisticated natural language chatbots that you can add to your applications. And it combines automatic speech recognition with natural language understanding. It integrates natively with our other AWS services. So you can integrate it into our cloud contact center, Amazon Connect. You can use it with our enterprise search tool called Amazon Kendra. And I'll get a bit more into that later on. And you can run serverless code using AWS Lambda for pulling up data from backend systems, calling APIs, that kind of stuff. It also integrates natively with Genesis Cloud. You can integrate it with any contact center that uses SIP trunking using our Chime SDK as well. And of course, it supports all kinds of other messaging platforms. It also provides you with this visual builder to build out your conversational flows. It's easy to use, drag and drop. Here I'm adding in a block for some back-end code. The little purple blocks there, those are for collecting slot values, things like date, time, location, to fulfill an intent. The little blue block on the end, that's a conditions block. So you can branch your conversation based on data you've collected. So maybe somebody's authenticated, they're a platinum customer, you choose to send them directly to an agent. But if they are any of the other levels, then they proceed through self-service, for example. I won't go too deep on how to build this, but I wanted to give you a sense of what is Amazon Lex before I then talk a little bit about Q&A bot on AWS. So Q&A bot on AWS is built on top of Amazon Lex, but it also integrates a lot of other language AI services that we have. So we use something like Amazon Comprehend. We can use that to detect the dominant language in a sentence. So if somebody chooses to type in Swedish or Czech, then we can see that it's a different language, and we can use Amazon Translate to translate to and from English to be able to go find the answer if we have that stored in English, for example. We can also integrate other services through that, and I'll get to that in a second. This is, you can deploy this over multiple channels. You have voice through the contact center. You have chat. You can put it on your website as a chat widget. You can set this up as a two-way text messaging chatbot if you choose to. You can deploy it as an Alexa skill. You can deploy it on Facebook Messenger, other messaging platforms. Like I mentioned, it's multi-language. You can use any of the 27 languages we support for voice in your contact center. And if you're using a text-based chatbot, Amazon Translate supports over 70 languages there. It's easy to deploy. There's a one-click that opens up something called a CloudFormation template. You can fill in your parameters, and it will deploy the entire solution for you in about 45 minutes. And it will also deploy out an easy-to-use graphical user interface for your content managers. So they don't need to have access to your AWS cloud account to manage any of this. They get a totally separate login. Here I've created a fictional Department of Motor Vehicles website here, the Octank State Department of Motor Vehicles. This is slightly on topic because we do have a couple of motor vehicle departments in the US that's using this solution in combination with Amazon Connect, our cloud contact center platform. It's also used by some state unemployment offices, universities. It's becoming quite popular. So here I have a little chatbot widget down in the corner. I can open up that chat widget. And here I can type something in. I'm typing something in Swedish, just asking, what is Q&A bot? It detects the dominant language, finds that's Swedish, translates it to English, finds the answer, and translates it back to Swedish for me for the answer. But in this case, I'm just going to click Continue in English here, and we can provide navigation buttons. So here I'm bringing up some categories of questions. This is similar to what you've seen on a lot of web pages. I choose that I have a question about driver's licenses in this case, and it brings up the questions that are available there. Sometimes customers find it's easier to find the question this way. So I'll ask about Real ID, which is something that we need in the US soon. Anyway, it brings back the answer. We can have hyperlinks in there for additional information. We can also do things like an embedded video. So in this case, I've embedded a video of our reInvent session. And you can also choose to embed images, product images. In this case, I have an image of a QR code for an app, for example. This is all fairly basic stuff. You can integrate this with a contact center. So in this case, I'm clicking to say I want to chat to an agent. And I can connect this to my Amazon Connect contact center. I provide my name here. So I type in Thomas Rinfus. And this will now connect me to the contact center instead. I'm going to switch over to a different tab I have here showing the agent experience. And you can see the chat coming in. We accept that chat. And now the agent is presented with a chat history of everything I've asked this bot, so they have some idea of why I'm escalating this chat. So you don't have to start from zero at this point. And since I entered in my name, it was able to pull up my customer profile in this contact center, and it can see my contact history, so it can see when I've contacted the contact center. So at this point, the agent is ready and can just start that live chat. How can I help you? So I wanted to show you this to give you a sense of what's out there and how this works before I start digging into how we're using large language models to make this a little bit more efficient as well. So what is a large language model? So a large language model, it's a type of artificial intelligence model that processes natural language data and produces meaningful predictions. It's essentially based on statistical probability. It's used for natural language understanding, text generation, and summarization. I think you've seen a lot of text summarization use cases. But in this case, we're leaning more on its ability to learn the relationships between words and their meanings and uses. So that's where we get into something called text embeddings. So what is a text embedding? A text embedding is where we measure the relatedness of different text strings. So essentially, we can take a phrase that you speak or you type, like, I want to talk to a human being, and we will turn that into a string of numbers, a vector, that represents the semantic and syntactic contents of that utterance, essentially the meaning of the sentence. And then we can, once we've stored that training data, so we can have training data saying, I want to speak to an agent, and then when somebody calls in live and say, hi, I just want to talk to a human being, we can, again, calculate the embedding for that, the vector, and we can calculate the distance between these and see how related are these. And if they score above a configurable threshold value, we can accept that as a high enough match and either return an answer to a frequently asked question. We can use that for intelligent routing. So if I store, I want to speak to an agent, that will match with something like representative, please. In a frequently asked question, we might have, what's the address of the White House? And even though somebody asks that using totally different words, like, what's the location of the president's mansion? The meaning is the same, and so you'll get a high relative match, and you can bring back that same answer. So how are we embedding this in Q&A bot? It gets a little bit advanced here. So we have a partnership with Hugging Face, which is similar to GitHub, but for large language models. So you can go and get fit-for-purpose language models that are open source on Hugging Face. And we use our service called Amazon SageMaker to deploy that language model in your AWS account. And then when you add these questions, inside of Q&A bot, we're using OpenSearch, which is an open source search and analytics suite. And that's where we store all your questions and answers. So when we store that question, we also store the embeddings for that question in OpenSearch. And we use knearest neighbor to figure out the relatedness at runtime there. And you can configure a threshold value as part of the settings. So an upside to this is you're not using a third-party API. You're not taking everything your customer is saying and sending that to a third party in some other country, but it's all kept within your own account. So does that make it really difficult to add a question? No. Here's our graphical user interface. Maybe not super pretty, but it's easy to use. We just click Add Question. We give it a unique ID. In this case, I've prefixed it with embeddings. You don't have to. It's just to keep track of it. I say, I want to speak to an agent. So I'm going to use this for intelligent routing. So I provide a response here saying, OK, let me route you to the next available agent. And I'm providing a little bit of what we call handlebar syntax here. I'll talk about that in a second. So we can set a session attribute. And I'll also type in 0 here. So if you're typing 0 on the dial pad, it can understand that as DTMF in the contact center. And I'll just save that. And now we have a different tab for test. And I can test this now by typing in an utterance. And we'll get back a response, and we can see how related that is. Let me switch to the next page that shows that a bit more in detail. So here, I'm going to point here a bit. So here we have the utterance that the customer is speaking. It gets matched against the embeddings for our stored utterance, and it gives you essentially a relatedness score. So in this case, it's between 0 and 1. So we get a 0.968 that is really high. I'm not surprised because these are super similar. I added in 0 here. That's for DTMF. And here, I'm saying return this answer and also set a session attribute called next action and give it a value of agent. So this stores a session attribute in my Lexbot, and it can return that to the contact center, so to Genesis, to Amazon Connect, what have you. So on my next page here, I'm showing how that can be used for intelligent routing. This is what it would look like in Amazon Connect. Let me skip to a recorded call. Let's see if we have any audio on this.
Welcome to the embeddings demo. How can I help you today?
I need to speak to somebody in customer service.
Okay. Let me route you to a representative who can assist you. Thank you for calling. Your call is very important to us and will be answered in the order it was received.
Obviously, I kept a lot of the standard messaging there. It's not something I would do for a production call center. So essentially, we talk to our Q&A bot here, we get back, we see if we get a response that's above our threshold level, which would indicate that we got an answer, so that's true. And if we did, then we check to see, did I set a session attribute, which I did in this case. And I'm checking that it's a Lex attribute, a session attribute called next action. And if the value was agent, then it comes out this agent leg, and I can transfer that to an agent. Now, of course, you can use this to transfer to other queues. You can have a question that would route to billing, one that routes to HR, one that routes to technical support. So it makes it really easy to create a main menu where you can have this intelligent routing. And if you build it smartly, then you don't even have to change the code in the contact center. You can have a contact center manager just go in, add a new queue, and then add a new routing rule, and it will do that dynamically. So here I have an example of having a single training utterance. I want to speak to an agent. I have a whole bunch of different ways that you can say that. And you can see that the scores are pretty high for all of these with even a single training utterance. I put a threshold value of 0.83, but let's say that you wanted 0.85, then operator and representative would have ended up below that. But then you can just add in some extra training data. In this case, I added in operator, please, and representative. So that will boost the ones related to that without lowering the scores for anything else. If you use this for frequently asked questions, what's the address of the White House? You can see things like what's the location of the president's mansion? Where does the president live? Where does the head of state reside? They all come back really high. But I want to caution you a little bit here. It's looking for things that are related, not necessarily the same. So on this last one, I'm asking, where's the Department of the Treasury? That's similar to what's the location of the White House. It's a location, it's of a government entity, and so this one comes back with a high score that was above my threshold value. So we're looking at using large language models again there to disambiguate that, to say, is this a good answer to where's the location of the White House, which we think we can get the large language model to say no, so we can avoid getting this back. Look for that in the future. It's also great for machine translation. So here I'm from Sweden originally. I said jag vill prata med en kundtjänstmedarbetare. I want to talk to a customer service rep. And so that gets translated into, I want to talk to a customer service employee, which might not be something you would have put in as a training utterance in English. But since we're now looking not for the specific words used, but the meaning of that sentence, it still matches really well. So this should work really well for intelligent routing across multiple languages. And then based on the language you could use that to append to your queue. So you route to, agent Swedish or something like that. So we have some experiments in progress. All of the stuff you've seen now, you'll be able to go, you can download and deploy this into your account today, and it all works like this. We have some stuff we're working on that's not available in the most recent version. So what we're doing here, we're looking at doing frequently asked questions without any questions. So essentially what we're trying to do there is we have a service called Amazon Kendra that is our enterprise search tool, where you can index your website, you can index your PDF documents, you can, we have connectors to Salesforce and other knowledge bases, and it can index the knowledge in there, so you can ask a question using natural language. It'll bring back text content, pages of text saying, I think this is relevant to your question. So what we're doing now is we're trying to create answers using generative AI. So instead of giving you a whole bunch of text, we allow you to prompt engineer yourself. We tell you, we give you an example prompt that it would use, but you can change it. And then we might ask something like, hold on, I need to actually read this. So essentially, what if my chatbot uses words that are not in the standard vocabulary? It then went out and found a chunk of text that talked about this. I just pasted half a blog post about best practices. And here, in this is the answer to that. But now I take my actual question and ask the large language model to summarize, just pull out the relevant part of this to answer my question. And so at the top here, you see the answer that comes back, essentially saying, use a custom vocabulary. And below here, this is more for debugging reasons. I see my entire chunk of text. In fact, it's not fitting all of the text. It's another page or so. but it's finding the specific answer to my specific question, not just text that's relevant to my question. So that's kind of where we see things going, where you don't use a large language model to answer your question with the risk of hallucinations. Instead, you use natural language understanding to find curated, factual answers that you've put out there or you've brought from your knowledge bases. And then you use large language models to massage that data to provide the section of that curated data that is relevant to the customer's specific question. And an upside to this is, based on which channel you're coming in on, you can say summarize this in 2 paragraphs if it's on chat, but over the phone you might say give me a 2-sentence response so that it's more relevant to the channel. And then you can do things like offer a text message over the phone, for example. Would you like a text message with a link to additional information so they could get the context of where that came from, or a link maybe to the specific website. I have some QR codes here. The top left is the solution page for this solution. Bottom left is a workshop, self-paced workshop, where it teaches you how to deploy it, how to configure it. I'm not sure if we have all of the large language model bits on there quite yet. Top right, how do you integrate this with our Amazon Connect Cloud Contact Center? Bottom right, if you don't have Amazon Connect, but you have something that can do SIP trunking, it's a blog showing you how to integrate it with any contact center. Thanks.
Thank you. Thank you. And I have to apologize. I introduced you with completely the wrong topic. It was about we did voice, yes, but hey, so much more. Any questions from the room? Do I see any hands? I don't have any hands online either. So I suggest that we just take it easy there's one question over there. That's wonderful. And there's a mic coming your way.
Thanks a lot. Can you hear me?
We can.
Okay. So thanks a lot for the excellent presentation. I noticed that you were talking about LLM. So LLM, is it somehow related or different than transformers?
So an LLM like ChatGPT is, that's a transformer. So you would have an encoder to encode that, but then essentially, yes, it's a transformer. And in this case, we're going to Hugging Face and we're grabbing the ones that are fit for purpose. So at Hugging Face, they have a leaderboard for text embeddings, and so you can find which of these open source language models performs best at text embeddings, and so that's the one we're using there. And now this last experiment there, now we're looking more at things like which ones are best for text summarization and extracting answers. And we've implemented with one there, but things every week another one is better, and so we're playing around with replacing that, updating, see what works best.
Wonderful.
And feel free, come grab me at any point during the conference. We can talk more about this or how language AI services can be used in general.
Thanks so much. And while we prepare, we're actually heading for the panels right now. There's a really interesting one in this room, and I would just say stay here, because this is about research, it's about future of conversational AI. But if you do want to shift to the other room, of course, that's all up to you. So I'll just give the panel a few minutes to install themselves. And I don't know about you, would you like to do some kind of, I don't know, I feel kind of, because it's just so much information there. And I've got a really short exercise. It's like a movement exercise. It's not funny at all. You don't make a fool out of yourself. But it's basically,